Let's learn the basics of the three main areas of noise countermeasures: SI, PI, and EMC. All products that use electricity around us emit a certain amount of electromagnetic waves, whether small or large. These electromagnetic waves can affect other electronic devices around us and even the human body. From electronic devices such as TVs, cell phones, and electric screwdrivers to cars and high-voltage lines, all electrical devices, and facilities in our daily lives emit electromagnetic waves. To prevent malfunction of devices or harm to the human body due to unintended electromagnetic wave emissions, the electromagnetic wave emissions of all electrical and electronic devices are regulated and managed. KC, FCC, and CE certifications are standards related to electromagnetic wave specifications. EMC is an abbreviation for electromagnetic compatibility. It means that both the EMI aspect, which does not cause electromagnetic interference to other devices, and the EMS aspect, which does not receive electromagnetic interference from other devices, must be satisfied. It means that the product maintains its original performance by neither sending nor receiving electromagnetic waves, and is called electromagnetic compatibility. EMC is divided into EMI and EMS. EMI is an abbreviation for electromagnetic interference, which means electromagnetic interference. It means that electromagnetic waves are emitted from a device and cause interference to other devices. It is divided into radiated emission, which flies through space and causes interference to other devices in remote places, and conducted emission, which causes interference through power lines or cables. In other words, EMI is divided into two types: radiated emission and conducted emission. EMS stands for electromagnetic susceptibility. It requires resistance to electromagnetic interference from outside without causing malfunctions or other problems. EMS is also divided into radiated susceptibility, which is immunity to radiated noise coming from outside, and conducted susceptibility, which is immunity to noise coming through power lines or cables. To summarize, EMC is also called electromagnetic compatibility in that it must satisfy both the EMI aspect, in which the electromagnetic wave emissions must be within the allowable standards, and the EMS aspect, in which it must have immunity to external electromagnetic waves. Electromagnetic interference between electronic devices includes radiated radiation, which travels through the air and causes interference in other devices, and conducted radiation, which causes interference through power lines or communication cables. There are two transmission paths from the noise source on the left to the damaged device when the interference electromagnetic waves exceed the allowable limit: a radiative path that travels through the air like a radio wave, and a conductive path through cables that are electrically connected to each other. In order to reduce these harmful electromagnetic waves, the most effective countermeasure is to take measures at the source, where the noise is generated. In addition to radiative and conductive noise transmission, noise can also be transmitted via composite paths, that is, from conductive to radiative or from radiative to conductive. When looking at the conducted radiation, the path through which the noise source and the victim device are transmitted is through the AC line. As the structure is such that the noise source and the victim device are connected to the same power line, when the external AC power supply line, i.e. the path from the outlet, and the noise source and the victim device use the same ground line, a noise transmission path is formed by conductive radiation. Here, common impedance refers to the impedance applied to the ground line when using ground, power, and data lines for communication using cables. Now let's look at the form in which the transfer takes place, changing from a conductive to a radiative path. This is when noise is radiated from the cable of the damaged device and affects the damaged device. In other words, This refers to when noise is radiated from the power or communication cable and affects the device. And when it changes from radiative to conductive and is transmitted, it refers to the form in which noise from the noise source device is radiated and transmitted through the cable. The path of radiant transmission that is carried through the air is the path from the noise source to the victim device, and there are cases where noise is transmitted from the cable on the noise source side to the cable on the victim side. So far, we can see that there are more and more noise transmission paths through cables than actual device-to-device noise paths. In this case, the cable can be considered as an antenna. The longer the exposed length of the cable and the higher the speed of data passing through it, the greater the occurrence and influence of this noise. Therefore, while noise countermeasures for the unit product itself are important, low noise design is necessary for the cable inlet and termination connected to the device. And shielding of the cable itself is also very important. Let's look at signal integrity and power integrity, which are important design considerations in high-speed systems. In signal integrity, the dictionary meaning of integrity is preservation and cleanliness, and signal integrity refers to the absence of signal distortion. In other words, it can be considered the same meaning as signal quality. And it is a technology that relates to how clean a signal is transmitted without distortion or interference while the signal is transmitted along the line in a circuit or system. Recently, with the increase in high-speed digital products, signal quality has become one of the important design considerations because it has a significant impact on the performance and speed of the product and also acts as a source of EMI. In other words, signal integrity means sending a complete waveform from the signal source to the destination without any distortion or interference. Power integrity refers to the quality of power, meaning how stable and clean the power is. It is an area that deals with how noise-free and stable the power supply structure is designed for the power lines and ground areas. Since the power lines are a structure shared by multiple circuits, noise generated in the power or ground lines of a specific circuit can affect other circuits simultaneously. So it is important to block this adverse effect, that is, decoupling. It is a cause of EMI, so careful design is required. In other words, power integrity is designing the power and ground layers or lines with low impedance to supply stable, noise-free power to all circuits and ICs. These SI, PI, along with EMI, are three important elements in high-speed system design. If there is a problem with SI or PI, it will affect EMI in addition to system instability. In other words, these three areas are all closely related to each other, so it is important to have a comprehensive design and countermeasure that considers all three, rather than looking at each area separately. Thank you. Bye.